So, what really causes the tectonic plates to move? That is the question that is addressed in this section. And really, the convection currents, which is convection, is the moving of hot, like the flow of colder and hotter materials through that moves in a circular pattern. And so here is like one demonstration of that. But here I wanted to show you this really cool current here. And I'm not able, maybe it's not going to come up for me. It's going to want a subscription. That's too bad. It was a pretty cool convection simulation. There we go. Okay, so in this simulation, you can see that this is a heater, like a radiator. It has the hot air come out, and then the cool air sinks back in from the bottom. So the cool air down below is getting pulled up, and the hot air is at the top. As the hot air cools down, it will actually sink because hot air will stay up, but as this hot air cools, it will go lower and lower until it goes in through the bottom. Then you can see that here in a liquid, a convection current, here is the same current in water. So the hot water here gets really hot and floats to the top and then circles around to the bottom. And then the same thing happens on land. Warm air rises and then it cools off and then it'll come up and warm over land. This was from Edumedia. I want to give them credit for that. So here we have those same currents that happen on under the earth. And these same currents are happening. And what is driving this current to happen? Well, it's actually the radioactive decay of rocks makes this enormous amount of heat. And this heat is the heat that makes these currents. So as rocks decay and become various isotopes, they're going to be giving off a great deal of energy, and it will really heat up, and that will burst through and come out. And in the meantime, once it cools off, it will get very heavy and dense, and it will sink back down because it'll be a lot heavier, and it'll be a lot lighter when it's very hot. So this current is what is driving plate tectonics. So the cooler material is denser and it's going back down. As the isotopes, the rocks basically decay and give off energy, it will heat up and it will also spread out and become less dense. That will make it rise because it's lighter, like a bubble coming up in water, and then it will harden and become very heavy rock that subducts back down. So that makes these convection currents. So there's a few other forces that we could talk about here. So basically, again, how do thermal convection cycles, or why do they matter? Well, or how do they cycle matter? They have old, cool material starts to sink down, and then that is heated up. Then that lighter, hot material rises and releases new material at the top. The outward spreading of the material pushes land apart, so it'll push the land apart as it goes. And then this crunches it and makes mountains like here, or it will subduct down at the plate boundaries. And there's two forces here that I want to mention. One important term that you need to know is ridge push. Ridge push, like is demonstrated here, is actually the weight of uplifted ocean ridge that is so heavy and dense. I mean, it's mountains, right? It's very heavy and dense. And that ridge will actually, under the, push with its weight. Just the weight of it will push the land to the side. Then And I love this illustration by your book. Your book talks about if you have like a tablecloth on a table and it's halfway hanging off and it starts to slide off, it's just going to pull everything off with it. You know, if you had a few knives and forks on there, it's just going to all pull that down with it. So that is called another term called slab pull, where it pulls down. So the ridges are kind of so heavy, they're sort of like pushing it down. It's just so heavy, like a massive pile of books or something that's so heavy. And then the slab pull is like a tablecloth that it's like slipping downwards and going underneath. So the slab pull is the weight of cooling rock sinking, and everything that's attached to it just gets pulled down with it. Cool fossils and rocks and all the cool stuff that's attached to it is all just going to slip down and be pulled with it. So as the mantle goes through the convection, the material is subducted under pieces of land. So like here's a continent, and as the mantle goes through this convection, the material is just going to subduct or go under pieces of land. So that was your basic understanding of what causes the plate motions.